Bayes theorem. The statement of Bayes theorem is, we will discuss on n mutually exclusive and exhaustive events. E1, E2, so on, En are n mutually exclusive and exhaustive events. Exclusive and exhaustive. Exhaustive events in S. E1, E2, so on, En are n mutually exclusive and exhaustive event in a sample space S. And A, B, any event in S intersecting every event. That means I equal to 1, 2, so on, n. And probability of A given E1, probability of A given E2, so on, probability of A given En are known. Then probability of Ek given A, Ek be the any event between E1 to En, then probability of Ek given A can be written as probability of Ek into probability of A given Ek by probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2 plus so on plus probability of En into probability of A given En. So this is actual statement of Bayes theorem. Whenever if you have this type of situation, n mutually exclusive and exhaustive events are there in sample space, A, B, an intersecting event which intersect every event of E1 to En, then to find probability of Ek given A when these values are known, we use this one. So now we are going to prove this one using simple previous techniques, conditional event, multiplication theorem. Using these all, we are going to prove. So what is actually given here? E1, E2, so on, En are mutually exclusive events. Mutually exclusive events means we all know when AB are mutually exclusive, then A union B equal to S. If A, B, C are mutually exclusive events, then A union B union C equal to S. Here, n events are mutually exclusive means A intersection B 5, sorry. A intersection B equal to 5. If A, B are mutually exclusive, A intersection B is 5. E1, E2, En are mutually exclusive events means EI intersection EJ equal to 5 for I not equal to J. So intersection of any two events you will find an empty set. And E1, E2, so on, En are exhaustive events means the union of these all should be a sample space. If AB are exhaustive, then A union B equal to S. ABC are exhaustive, A union B union C equal to S. Like that, E1 union, E2 union, so on union, En equal to sample space. So this is given. And what next given? AB an event in S intersecting every E. And these E1, E2, En are n mutually exclusive. That means they are not intersecting each other. If you observe in a Venn diagram, you can easily understand in sample spaces. For example, this is an E1 event, this will be another E2 event. So from here to here, this is E2 event. Like this, we are having n mutually exclusive and adjacent event, E1, E2, E3, so on, up to En, n mutually exclusive. So they are not intersecting each other, but if you combine all E1 to En, you will get sample space. And here, AB one event which is intersecting all E1 to En. For example, if you assume like this, A be the event which intersect all n events, then we all know A can be written like this. A is subset of S. A is an event in S. E1, E2, En also, every event is subset of S. So here we can write A can be written like S intersection A or A intersection S. A and S, common point if you find, you will get S only. S is universal set. A is intersecting S. So A intersection S will be A, B intersection S will be B, E1 intersection S will be E1. So like that, we can write A as A intersection S. Now what is S? S from above adjacent events, in the place of S, what we can write? E1 union, E2 union, so on union, En. So from above, if you assume this one as equation 1, from 1, S can be written like this. A is an event intersecting every EI. A can be written like this. And S I replace from here as E1 union, E2 union, so on union, En. Using set theory, this can be written like this. A intersection E1 union, A intersection E2 union, so on union, A intersection En. Okay, this is A value. Now I am taking probability on both sides. What you will get? Probability of A equal to probability of A intersection E1 union, A intersection E2 union, so on union, A intersection En. We all know that E1, E2, En are n mutually exclusive events where A is intersecting with them. Because A is intersecting E1, E2, so on En, and E1, E2, so on En are mutually exclusive events, then what happens? A intersection E1 and A intersection E2 does not have common part. Because E1, E2, so on En are mutually exclusive. What I am saying here, A intersection E1, comma, A intersection E2, so on, A intersection En are mutually exclusive events. Mutually exclusive. We all know that when two events are mutually exclusive, from axiom 3 of probability, what we can say, if A comma B are mutually exclusive, then probability of A union B can be written as probability of A plus probability of B. Basing on that axiom 3, what we can write RHS part of this, probability of A now can be written as probability of A intersection E1 plus probability of A intersection E2 plus so on plus probability of A intersection En. So which is called total probability. We call this one as total probability. Now using multiplication theorem on probability. This is using axiom 3. From axiom 3 of probability, we written that one. Here, next I am applying multiplication theorem. From multiplication theorem of probability, what it says? Probability of A intersection B can be written in two ways. Probability of B into probability of A given B, or probability of A into probability of B given A. So like that, probability of A intersection E1 can be written like probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2 plus so on plus probability of En into probability of A given En. So this is probability of A value. But what we need to find? We need to find the conditional event, conditional probability of this case, Ek given A. We all know that probability of A given B is probability of A intersection B by probability of B. Basing on that, one can write like this. Probability of Ek intersection A by probability of A. Using conditional probability formula, probability of A given B can be written probability of A intersection B by probability of B. Using this I written there. Now using multiplication theorem on probability, probability of Ek intersection A can be written like this. Probability of Ek into probability of A given Ek using multiplication theorem. Multiplication theorem on probability. So probability of A we know. Already we written here. By assuming this one as equation 2 from 2, what we can write in the place of probability of A? Probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2 plus so on plus probability of En into probability of A given En. Are you clear? So like this, one can easily prove the probability of Ek given A in Bayes theorem. Any doubts you may express? First box contains 2 black, 3 red, 1 white box. Here there are 3 boxes. Box 1 has 2 black, 3 red, 1 white. Second box has 1 black, 1 red, 2 white box. Third box contains 5 black, 3 red, 4 white balls. So these are the balls we are having. So what happened here? From the 3 boxes, randomly one box is selected. We don't know what is that box. One ball is drawn from that box. For example, that is red ball. What is the probability that red ball came from second box? So randomly we selected one box, we don't know what is that box from the 3 boxes. From that we draw a red ball. Now the question is, what is the probability that that ball is came from second box? Okay, for that, first we are taking 3 events. Let B1, B2, B3 are the events of getting boxes 1, 2, 3. Getting boxes. Box 1, box 2, box 3. Now, what is the probability of getting box 1? How many B1s you are having? Only 1 B1. Out of how many boxes? 3 boxes. So 1 by 3. What is the probability of getting B2? How many B2 boxes you are having? Only 1 box. 1 is favorable. Total number of boxes are 3. What is the probability of getting box 3, B3? How many B3s you are having? Only 1. 1 by 3. Now, I am assuming let R be the event of getting red ball. Event of getting red ball from any box. So now, what is the probability of getting a red ball from box 1? Box 1 is selected first. Next we are getting red ball from box 1. How we will get this red ball from box 1? How many red balls you are having in box 1? How many red balls? 3 red balls. So favorable is 3. So total number of balls, 2 plus 3, 5. 5 plus 1, 6. Which can be written as 3 1 jar, 3 2 jar, 1 by 2. So probability of getting red ball from box 1. So here selecting first box, next getting ball. So first event is selecting box. Next coming to the second one. Probability of R given B2. R given B2. That means from the second box, what is the probability of getting red ball? In the second box, if you observe, in the second box you are having only one red. How many total number of balls you are having? 1 plus 1, 2. 2 plus 2, 4. 1 by 4. Similarly, what is the probability of getting red ball from box 3? In box 3, how many red balls you are having? 3 red balls. Total number of balls, 3 plus 4, 7. 7 plus 5, 12. So 3 by 12 means 1 by 4. So these are the given information from the given question. Next, what we need to find? We need to find a red ball is drawn first. A red ball is drawn from any box. We don't know what is the box. We got that red ball. We need to find out what is the probability that ball came from second box. How much probability is there to get from second box? There are 3 boxes. We don't know the numbers. Randomly we selected one ball, a red ball from one box. But we don't know from which box we get that red ball. Now we need to find out the probability of getting that red ball from particularly a second box. So here a red ball is selected first. We need to find what is the probability of getting that red ball from second box. That means reverse. We know R given B2. We need now B2 given R. Whenever these information we are having, there we apply Bayes theorem. Using Bayes theorem, we all know that using Bayes, I am going to write probability of B2 given R. What is probability of B2 given R? Using Bayes theorem. Probability of B2 into probability of R given B2 by probability of B1 into probability of R given B1 plus probability of B2 into probability of R given B2 plus probability of B3 into probability of R given B3. Next we need to substitute all the values. What is probability of B2? 1 by 3 into probability of R given B2 1 by 4 by substitute all the values. Probability of B1 1 by 2, sorry 1 by 3, probability of B1 1 by 3, probability of R given B1 1 by 2, probability of B2 again 1 by 3, probability of R given B2 1 by 4 plus probability of B3 1 by 3 again into probability of R given B3 1 by 4. Now if we simplify this all, this is a probability. The answer should be lies between 0 and 1. That means 0 point something. You will get here answer 1 by 4 using calculator. 0.25 is the probability. 25% chance to get red ball from the box. So like this one can easily evaluate probability of getting a ball from one box when the data is given like this. When data describes about 2 events, immediately you need to get Bayes theorem in your mind. Here 2 events we are discussing: drawing ball, selecting box. Any doubts you may express? A businessman goes to hotels XYZ with 20%, 50%, 30% of the time respectively. It is known that 5%, 4%, 8% of rooms in XYZ hotels are faultily plugged. what is the probability that businessman room having faulty plumbing is assigned to Hotel Z? Here the question is, the businessman goes to 3 hotels. The probability of going is given clearly, the percentage 20%, 50%. 20% means 20 by 100. 50% means 50 by 100. Next, the 3 hotels have few rooms or faulty plumbing. The percentage of rooms having faulty plumbing is, in 3 hotels, is given clearly 548. Now, a room is assigned to businessman, that is faulty plumbing. Now we need to find that is from hotel. Here room is assigned already. So what is the probability that faulty plumbing room assigned to the businessman is from Hotel Z? That we need to evaluate. So first we are framing given data. Then we can understand which principle we have to apply for solving this problem. First, we are taking, let A, B, C be the events of selecting hotels X, Y, Z respectively by the businessman. Now, what is the probability of A? Probability of A is given 20%. A means X hotel, A means X hotel here, B means Y, C means Z hotel. So, probability of A is 20%, which is called 20 by 100. Probability of B is given 50%, 50 by 100. Probability of C also given, Z hotel 30%, 30 by 100. Now we need to find the faulty plumbing probability. For example, let F be the faulty plumbing room. Let F be the event of faulty plumbing room in XYZ hotels. Then what is the probability of having faulty plumbing room in X hotel, Y hotel, Z hotel are given clearly. If you select hotel X, that means first select hotel X. What is the probability of having faulty plumbing room? F given X. What is the percentage given? 5%. 5 by 100. What is the probability of having Y hotel faulty plumbing? First select the hotel, next see the percentage of faulty plumbing rooms. So first we are selecting the hotel, that's why that is first event, I keep Y here. This is 4%, 4 by 100. Similarly, probability of F given C, also we have 8%, 8 by 100. Now, with this data, we need to find a faulty plumbing room is assigned to businessman. Now we need to find that is from Hotel Z. So what is the first event? First he is saying that room is assigned already. That means now faulty plumbing room is assigned to businessman. Now we need to find what is the probability that faulty plumbing room is from Hotel Z. C represent Hotel Z. So this we need to find. Already given probability of F given C. Whenever if you have these type of data, so X means we took that one as A, Y is B, Z is C. So X, Y, Z we assumed as A, B, C. Okay. Now probability of C given F from Bayes theorem. Using Bayes theorem, Probability of C given F is probability of C into probability of F given C by probability of A into probability of F given A plus probability of B into probability of F given B plus probability of C into probability of F given C. Do you know the values of probability of C, F given C? All values are given very clearly. Probability of C is 30 by 100 into F given C is 8 by 100 by probability of A. Probability of A 20 by 100 into F given A 5 by 100. Probability of B 50 by 100 into F given B 4 by 100 plus probability of C 30 by 100 into F given C 8 by 100. Now if you calculate these all values using your calculator, you will get an answer 4 by 9, which is 0.44. There is 44% of probability of getting a faulty plumbing room from Hotel Z. So like this, one can easily identify the problem is from base theorem whenever there are two different events. Whenever if you have a question asking what is the probability of happening one after happening another, then you can use base theorem very easily like this. Any doubts you may ask. For example, instead of Hotel Z, if you ask what is the probability that faulty plumbing room is assigned to Hotel Y, you need to find probability of B given F. Probability of B given F means probability of B into probability of F given B. The numerator only changes. If it is from X, numerator will have probability of A into probability of F given A. Here A given F. The denominator will be same for all.